Hi, good morning, class. We are moving into volume now. We did some three-dimensional work yesterday, and now we're in section 2 with volume of prisms. Remember, prisms are figures that have two bases, and they're connected by rectangles. That's from our notes yesterday. So volume, first of all, volume, what is it? It's the measure of space inside of a three-dimensional figure. How many cube or cubic units can fit inside of our prism. That's what we're looking at today. So this is the formula you want to write down. Volume equals capital B times H, as well as the definition. Capital B, that's kind of the tricky thing, because that's not the same for every figure. But if you read here, V, or the volume V of a prism is the area of the base, which is capital B, times the height. So capital B is the area of the base. So if we have a rectangular prism here, it does not matter what we choose for the base because they're all rectangles. But this here is a triangular prism. So we name these off their bases. This is a triangular prism, so the triangle has to be the base. So in order to find the volume, I need to find the area of the triangle base and then multiply by the height. The height is always the distance between the two bases. Okay? So let's start off with a rectangular prism because that's the most straightforward one. Because basically, area of a base, area of a rectangle is length times width, and then times the height, or the third number that we haven't used. So let's say this bottom rectangle is our base. It doesn't have to be that one, but that's what we're going to choose. So that's going to be 3 times 4.2 times the height. We're going to take 5 as our height, or how tall the prism is. So I'm just going to multiply those three numbers together. And so 3 times 4.2 times 5 is 63 cubic centimeters. So how we write that answer is 63. We put centimeters, and then a little 3 is the exponent, or cubed. Okay, so this means 63 cubic centimeters. So we're looking at how many cubes can fit inside of here. So 63 of them that are 1 centimeter by 1 centimeter by 1 centimeter. Alright, guided practice, we want to find the volume of this rectangular prism. Again, we're just going to multiply the three numbers right there. 10 times 13 times 21. Now, when we get into triangular prisms, it's a little bit different because, again, we name these by the base. The base is a triangle. Okay, whether it's laying on the bottom or on the side doesn't matter. We have to use a triangle as the base. Okay, so look at this triangle here. This is a triangle. It's 2 here. How long is the bottom part of this triangle right here? Well, that matches up with this down here, which is 6. So I want to find the area of that triangle. Well, the area of a triangle is base times height times half. Okay, so 2 times 6 is 12. Half of 12 is 6. So that's the area of my base. My area of a base, I'll just write it again, equals half times the base times the height. Doesn't matter the order. And that's going to equal 6. So my capital B is 6. Times my height is the distance between my two triangles, which is 7. 6 times 7 gives me an answer of 42 cubic centimeters. That was a bell. Cubic centimeters. Alright. Same thing with these triangular prisms. I have to find the area of the triangle first, and then multiply by how far away they are. So look at this one. The triangle is not on the bottom, but the triangle is still the base here, because it's called the triangular prism. Alright. So no matter how we lay it, it's always going to be the base. Okay, here's a real world problem. We have a room. Air conditioner can cool a room with a volume of 1,600 cubic feet. If these are the dimensions of the room, the length and the height, what would the width be? Well, let's find out. So we can cool up to 1,600 cubic feet. So I want 8 times 16 times my length. I don't know. Sorry, width we did, so I'll do a capital W. Width is what we want to know. I want that to equal 1,600. Well, this is an equation now. Okay, so I do 8 times 16, just to figure out what that is. I believe that's 128. Times W equals 1,600. To solve this, this is 128 times W equals 1,600. So just like we did equations, I have to divide both sides by 128. I do the opposite of multiplying, which is dividing. And so I do 1600 divided by 128. That will tell me my width of the room is 12.5 feet. So the width would be 12.5 feet to make this a 1600 cubic foot room. Alright, let's kind of work backwards. Problem whether the air conditioner can cool the whole room or not, or what the dimensions have to be. And then we have composite figures. So we have multiple choice here. Alright, but if I look at this, I want to find the volume of this figure. Well, I see a triangular prism here, triangle front and back, and a rectangular prism. So I'm just going to find each volume and add them together. So this one right here, the triangular prism, let's do that first. The area of my base for that one is half the base times the height. So half times 10 times 2 is 10. Times how far is it from this front triangle to the back triangle? Well, from this front triangle to the back triangle is this distance right here, 3 feet, because they go back 3 feet there also. So take that times 3, that's 30. So the volume of the triangular prism is 30 feet cubed. Now that's not my answer, even though it's one of my options over there, right there. I also have this rectangular prism, which a rectangular prism I just multiply the 3 dimensions. You know, it's 2 tall, it's 6 long, and it's 3 wide. So to find the volume of that, I do 2 times 6 is 12. 12 times 3 is 36. And again, this is not my answer. I need to add these two together to get my total volume. Alright? So 30 plus 36 is 66. So my answer is C right there. Okay? If you want to practice a little more, here's one more guided practice of 2 rectangular prisms down here. But just to kind of show you here. Add them together, answer is C. Okay, that's all I got for today. Have a wonderful day of school.